Welcome friends, if you like to learn about the test plugs and the protection systems, you are at the right place. So in this video we will going to see what is a test plug and how it works. So if you see the front side of test plug, so you can see this test plug is basically front side. You have access of some terminals, so you can see the black terminals tag and the yellow terminal tag. So here you can see the yellow side is basically the side where the equipment or live equipment is connected. Means if the DC supply is coming through, it will be entered at the right hand side on the yellow terminal, and then it will leave from the black terminal, okay, to the panel. So for example, if you need to connect the current transformer, so you need to bring the current transformers from the yard to the terminal block of the panel, and from the terminal block you need to bring it up to the odd number. So the odd number side will be the side where you will connect your live connections, and the dead side or the panel side is basically the black color, the even connections. So for example, if you want to do the CT injection, you need to insert the plug in it, and then you can connect your CT links, CT cables from the testing equipment to these terminals like 2, 4, 6 depending upon the connections. So if I take you to the schematic drawing here, so here you can see this is schematic drawing of the test plug. So you can see the odd numbers and the even numbers. You can see here 1 and 2. So 1 is basically, it's clear that 1 is here is coming from the yard, and 2 and 4 here is connected to the panel. So if you go to the sheet number 33, this is the sheet number 33, column number 3, you will be able to find out where this plug is being used. So we will go to sheet number 33. So this is sheet number 33, column number 3. So here you can see this is the test plugs number 87L.1. okay, so 87L.1, and you can see 1 here is connected to the solid DC. This is the solid DC which is coming to X51, and it is connected to terminal number 1. So this is the odd side of the terminal that was shown in white color. Sometimes it's shown in red color, and the panel side is shown in the white color. So there are different schemes. We are here reviewing an RMS plug where the live side is shown by, here you can see the yellow color, and the panel side or the dead side is shown in the black color. So if you further see here, this is the finger. So if the test plug is not inserted into the test block, then these 2 points are basically connected. It means that there is a connectivity between 1 and the 2. okay, in the schematic drawings, the test blocks are shown always as their front cover, which is basically, you can see when you want to put the dust cover on the test block, it is removed. So the drawing is shown in such way, and you can see this is the binary output, and it's coming from again 4 and the 3. So this is the configuration in the schematic drawing. So we'll move on and see how the test plug further works. So here you can see this is the back side of the test block, and these are the terminals where you can connect your wirings. So the left hand side is the odd side, and the right hand side is the even side once again. And here you can see this is basically the wiring. Even inside the test block, they are using 2 different color code of the wiring. So further you can see this, they are providing that this product is flame retardant, plastic material is flame retardant, and the color coded as well, as I have explained. And this is the product here under review is 4M200-01. So this is the connections from the terminal to the test block. So the class here is ib2x, and here you can see the polarization is available here. Okay, now if you want to insert the plug, so this is the test plug. If you want to do the testing, you need to put the plug in the test block. So if you put the plug, so you have this access of the terminals separately, left hand side and the right hand side. You can see this is 1 and this is 2. So you can connect, if you want to test, for example, you want to inject, so you need to connect on the black side, black terminals which are connected to the relay, not the yard. Okay, so you can see now this is the internal configuration of the test plug. So we are going to insert the plug into the test block and we will see how it's working. So here you can see this is the two, basically this is the two sides of the test plug, and both are in the center. You can see both are isolated from each other. So this plug, what it is doing, before inserting the plug, if you go back, you can see before inserting the plug, the odd side and the even side both are connected together. Okay, both are basically shorted. So once you insert the plug, what the plug is doing, it is basically isolating the side. Like for example, this is 1 and 3, it will isolate 1 and 3, and this finger will be bringing continuity to this finger, and you can get the continuity from this banana pin. So here you can see again repetition. So, and another thing to note here is that they are basically making the contact before breaking. So they are making the contact before breaking the contact. This is the additional feature that is being provided in this RMS plug. Okay, now the plug is completely inserted here. So now you can do your testing. So crimped wire contacts, zero solder usage. This is the plastic boards of the high insulation. They are providing the insulation also to protect it from the corrosion. The cable size, here you can see they are defining 2.5 mm, and this is the top cover. Okay, so these are different configurations. So if you want to know more about make and break, so this that one term I use, make before break. So here you can see this is example. So this is basically example of break before make. So you want to shift the contact from 1 to 2. So simply, obviously you can see during the shifting, the contact between 1 and 0 will be break. So while this contact is moving in the intermediate position, it is not connected to 1 or nor it is connected to 2. So we can call this one as break before make. So when it's connected to 2, so this will be basically, we can call it making. So first you like to break the contact of 1 and 0, and then you want to make the contact between 0 and 2. So we can call this connection as break before make. So another connection is make before break. So this is example of make before break. So as this is moving, first this contact will be reaching at this point in the center. When it's moving in this direction, you want to change the contact from 1 to 2. So time will come when this contact is somewhere here. So it is somewhere here. So it is touching the both points 1 and 2. So you can see here it is making the connection between 2 and 0 first, and then it is further breaking the connection. So it will first make the connection between 1 and 2, and then still it's move on, and then it will be staying somewhere here, and then it is making connection between 2 and 0 only. So this will be, again, if I can explain in some better way, 3 1 2 3. So first position is this one. So if you want to change this one. So second position will be somewhere here. So you can see the contact between 0 and 1 2 is make, and then at the third step it will be in the center, and then contact between 1 and 2 will be break. So this make before break is especially important, that this technique is basically used, if you know, in the tape changers, on load tape changers. So in the on load tape changers we don't want to have interruption in the current, so we are using this, the technique of make before break. And another technique, another purpose of using make before break is basically the current transformers. So again, the current transformers is basically a circuit in which it's not allowed to open the series circuit at any moment, even for milliseconds or at any place. So because opening the series circuit will induce high voltage, okay, and that's dangerous for the equipment, and CT also can get damaged during this process. So this is about the schematics. So further I can show you the connections, how the CT connections are basically connected. So if you see here again, you can see this is the current transformer. This is coming from local control cubicle bay 01, and it's coming to this terminal X1-1, and then it's coming to the odd number side of the terminal block 21, 23, 25 and 27, and then from here it is going to the relay from the even number of the terminal blocks. So in this way you can learn about this test plugs, and if you like to basically get the complete training on it, you can check the link in the subscription, so you can subscribe to complete training of schematics. I will say thank you very much.